Welcome to another video. In this question on the May 2019 paper. Okay, so in this question we're going to multiply. It says find the matrix product of negative 1, 3, 4, 8 multiplied by k and 5. So in doing this question we're going to multiply the rows of the first times the columns of the second. Okay, so remember that, and so you can look at one of our previous videos that we did matrix multiplication in order for you to go and add the columns of the second. Okay, so it's negative 1 times k plus 3 times 5. Okay, so that's the first row multiplied by the column, and then we are going to move to the second column, which is 4h multiply by k and 5. 4 and h multiplied by k and 5. So it's going to be 4 times k plus 5 times h. So we can simplify this now. So negative 1 times k is equal to negative k plus 15. So that's the first row. Then the second row we have 4 times k will give us 4k, and 5 times h will just give us 5h. And that's how we would have found the matrix product of negative 1, 3, 4 and h multiplied by k5. So moving on, we're going to move to the second part of the question. Say hence find the values of h and k that satisfy the matrix equation. Here, so earlier we had, when we multiplied this part, we got negative k plus 15. Then we have 4k plus 5h. Okay, so basically that would be the result of that, and that is equal to 0, 0. So therefore, if two matrices are equal, then what it means is that corresponding elements are also equal. So therefore, negative k plus 15 is equal to 0. So if negative k plus 15 is equal to 0, then we have negative k, take this 15 across the equal sign, is equal to, it's positive 15 here, so when it goes across the equal sign, it becomes negative 15. So negative k is equal to negative 15. So therefore, if we divide both sides by negative 1, we are going to get k is equal to 15. So now that we know that k is equal to 15, the next part of the question, so we now need to find what h is. Again, remember, if two matrices are equal, then the corresponding elements are also equal. So therefore, 4k plus 5h is equal to 0. But from here, we got k to be equal to 15. So therefore, 4 times 15. So we're going to substitute k with 15, because k is equal to 15, plus 5h is equal to 0. So 4 times 15, that will give us 60. So 60 plus 5h is equal to 0. Okay, so therefore if I take this positive 60 is or we can say if we subtract 60 from both sides of the equation, then we are going to get 5h equal to negative 60. So if 5h is equal to negative 60, then if I divide both sides by 5, we say that h is equal to negative 12. Okay, so basically then we have k is equal to 15 and h is equal to negative 12. So that's how we would go about performing this matrix multiplication and finding what the value of h and k is using equivalent matrix. So I hope your lesson reads is asking us to use a matrix method to solve the simultaneous equation. So here we have 2x plus 3y equal to 5 and negative 5x plus y is equal to 13. So in our previous video, we looked at how to solve simultaneous equations using the matrix method. So let's go. So first we need to we want to write the matrix multiplication in the form of ax is equal to b, where a is equal to the coefficients of the variables. So we have 2, 3, negative 5, 1, and the coefficient of y here is 1. So that's matrix A. Matrix X is equal to the variables. So whatever the variables are is xy. And matrix B is equal to the solutions themselves, which is 5 and 13. Okay, so that's how we would have written finding the matrix, okay, or the matrices. So what we're going to do now, so we need to remember that ax is equal to b. So in the previous video we said that if we multiply both sides by a inverse, is equal to a inverse times b. Now, so remember, when we multiply a matrix by its inverse, on this side we are going to get the identity matrix. So these two matrices automatically will be equal to 1, 0, 0, 1. And say we want to multiply by an xy, it's going to be equal to a inverse times b. So therefore xy is equal to a inverse times b. So what that is telling us is that the solution of this matrix question, or the simultaneous equation, can be found by multiplying the inverse of a, the inverse of this matrix here, times b. So let's go. So that's what we're going to do now. So we have negative, so a is equal to 2, 3, 5, and 1. Okay, so therefore a inverse is going to be equal to 1 divided by the determinant of a times the adjoint of a. So how do I go about finding the the determinant? So it's 1 over the determinant. How go about finding the determinant again? Remember, it's a product of the leading diagonal minus the product of the non-leading diagonal. So we have 2 times 1, and the leading diagonal is this diagonal here, right? So 2 times 1 minus 3 times negative 5. Okay, so that's times the adjoint. Whenever we're finding the adjoint of A, or the adjoint of any matrix, remember this, these two, we switch the positions of these two. So 1 becomes the first element, 2 becomes the fourth element, and then whatever signs these have, we give them the opposite sign. So we have a negative 5 here, so we're going to get a positive 5, and we have a positive 3, so we're going to get a negative 3. So let's simplify this. So we have 1 over 2 times 1 will give you 2 minus a negative 15 times 1, negative 3, 5, and 2. Okay, so here we have a two negative following each other, so automatically that's going to become plus. So that becomes 1 over 2 plus 15 times 1, negative 3, 5, and 2. So that now becomes, so A inverse is now equal to 1 over 17 times 1, negative 3, 5, and 2. Okay, so that's A inverse. All right, so this is what A inverse is. So remember, we said that xy is equal to A inverse times B. So if A inverse times B, so what we are simply going to do is 1 over 17, 1, negative 3, 5, and 2, multiply by whatever B was, and B was what? 5 and 13. So remember now, when we're multiplying matrices, it's the rows of the first multiplied by the columns of the second. Okay, so we're going in an L formation. Okay, so we're going to keep the 1 over 17. So let's keep the 1 over 17 here. So we have 1 times 5 will give us 5, and then negative 3 times negative 3 times 13 will give us negative 39. And then we have 5 times 5 will give us 25, and then 2 times 13 will give us 26. Okay, so we have 1 over 17 times 5 minus 39 will give us 34. Negative 34, sorry, 5 minus 39 will give us a negative 34. That is why, guys, please do not rush whenever you're doing your questions. Ensure that you work with your signs carefully. Okay, be careful with your signs. So we have 5 minus 39, that will give us a negative 34, and 25 plus 26 will give us 51. So basically, x and y would be equal to what the answer we get here. So we have xy is equal to 1 over 17 times a negative 34 divided by 51. Okay, so therefore, so this is scalar multiplication now. So whatever is on the outside must be of this matrix must be used to multiply what is on the inside of the matrix. So we have negative 34 times 1 over 17 is the same as saying negative 34 over 17, and then 51 times 1 over 17 is the same as saying 51 divided by 17. And this is what x, y is going to be equal to. So therefore, negative 34, so if you have negative 34 divided by 17, is going to be equal to negative 2, and 17 divided by 51 divided by 17 rather is going to give us 3. So therefore, x is equal to negative 2 and y is equal to 3. Again, why is that possible? Because these two matrices are equal, and once two matrices are equal, then corresponding elements are equal. So therefore, this is equal to negative 2 and y is equal to 3. So don't forget that now, gentle people. And again, you watch this video, remember, you are able to pass this. You are able to do this. Range 1 is not out of your reach. Remember, heights of great men reached and kept was not attained by sudden flight, but they, while their companions slept, kept toiling through the night. So therefore, go ahead, do the hard work, and at the end of the day, you will be surely satisfied when you do your exam. Peace.